my friend.
Woo! Hey, 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 hey!
That's right. Famous intro. Welcome, my friends, to another math video.
Yeah, I've been waiting for so long.
Yes, it's finally arrived. And look at what we have here, my friends. Who are you? My goodness, you look like a sheep. Yes, with a cowbell. Is that a cowbell or with a sheep bell? I don't know. Hey, welcome along, my friend. You look looking all like, you look like you got some fancy shoes on the way they painted those things gray. I don't know. You going somewhere? Anyway, hey, just giving you a hard time, my friend. We love your wool. Now, let's get down to business. We have ourselves another engageNY-Eureka. Yes, math video. And our learning target here. This is our objective. Yeah. It says that we're going to be dividing decimals using place value understanding, including remainders in the smallest unit. All right. Look at our friend here. Yeah. Mr. Cool. Yeah. Oh, you're really hip. That's what it is? Mr. Hipster. Yeah, you're cool. Right on, man. I dig it. Anyway, let's get started. We have ourselves a decimal. And it looks like in a whole number. And again, always reminding ourselves that 1.7 and 1 7/10 is our dividend. And we're dividing that dividend to take that number and we're going to divide it into, that's right, two equal groups. We need to have the same quantity in each group. For this particular activity, the first thing I'm going to say is, well, if we're going to divide this, we probably want to start with our largest unit. So our largest unit here is 1. Can it be divided into two groups? No, it can't. Okay, so each group is going to get how many ones? They're not going to get any. So what I'm going to do over here, I'm going to go ahead and write the algorithm as I go along. So here's my 1 7/10. We're dividing by 2. And we said 2, in this case, we could not divide 1, okay, into 2. So we end up with 0 here. Now I'd like to go ahead and bring that decimal point up right away. Up, and away. There you go. Right there. So that way we get that lined up immediately. Even though we had to put a 0 in the ones place of the quotient, in this algorithm, we need to keep sharing, okay? So how can we keep sharing this single ones disk? Well, we can't. So I'm going to take this single one disk and I'm going to go ahead and I'm just going to put this right here in the ones place. I guess I should have started off with that first, shouldn't I? Yeah. So let me do 7/10. And keep in mind as I'm doing this here, you don't actually have to write the numbers on each one of the disks. I only did this for simplicity, so you see the connection, that's all. You could put little circles, little black circles work just fine. The idea is the number of counters that you have. Okay, so we weren't able to share the 1. So that's a problem because we have to kind of keep sharing, but maybe we can unbundle, as they say, unpack, decompose, or exchange that 1 for 10/10, since we know that 10/10 is equal to 1 whole. So let's do that. Okay, now I've shown you how we have that 1 whole now is turned into 10/10. So let's cross off that 1 whole. So now the question is, yeah, I have 17/10. Can I do 17/10 divided by 2? Yes, I can. Now I can't do it without having some kind of remainder. And I could put 8 disks in each group because 8 plus 8 is 16 and I would have 1 left over. So I'm going to come back to my algorithm over here and show that. So now I have 17/10 coming across here. Now I can go ahead and divide that 17 into 2. Okay, that's going to give me 8 in each group. And 8 times 2, of course, is 16. And I'm going to subtract. So I should have 1 left over. And if I do that, I could also show it on here. So there's 8 that I've taken. That's one group of 8/10. But as you can see here, we have 1 left over. So now we know there isn't any way that we can keep sharing that 1/10. There's only 1/10 and we have two groups. But what we could do is like we did the last time by taking that 1 whole, we're just going to go ahead and take that 1/10 now. And then we can make that into 10/100. Okay, there's my 10/100 for that 1/10 that I exchanged it for. We'll go ahead and cross that 1/10 off now. So we're left with just 10/100. Now something to keep in mind is we haven't changed the value of the problem by crossing that 1/10 off. All we've done is just exchanged that 1/10 for 10/100, which is exactly the same value. I can show this by putting a 0 in the hundreds place. So I'm going to go ahead and record a 0 in the hundreds place of the algorithm. There we go. And by putting that 0 on the end of that dividend, I'm not changing the value. It's actually considered an equivalent decimal. It means the same thing, so I haven't made any changes. Now the question is, we have 10 hundredths. Can we divide those 10 hundredths into two groups equally? Yeah, isn't that great? Yeah, because 10 is a multiple of 2. 2 times 5 is 10. So we can actually make two groups. So here's one group of 5, and here's that other group of 5. Still making my two groups. And I could have actually even circled them to just show this so you don't get confused, but we're divided by 2, so we're trying to make equal groups. The same thing over here. Now let's go back to our algorithm. See, now we have our 10 hundredths. That was our 1/10 that was left over. Now by just putting that 0 on there, we made 10 hundredths. Now we can take that 10 hundredths and divide it by 2, which of course is 5. And then we end up with 10 over here. And what do you know? No remainder. Do you love it? Can you feel it? Yes, I can feel it. Okay, my friends, I'm getting far too excited. It's just that math, it always works out. Or at least most of the time, right? Until we get to a problem that's a little bit more challenging. Hey, so we've recorded all our information. Do we have any more units to share? No, we're done, right? We end up with a 0. So now let's look at our quotient. So that's our answer here in a division problem. So in unit form, we have 0 ones, 8 tenths, 5 hundredths. Okay? But in standard form, and the way that we would just say that is 85 hundredths. Okay, so I'm going to go ahead and solve another division problem next to this one here, and then I'm going to ask you a question. Of course, something that you're going to ponder as I'm doing the video. Okay, so we can't take 6 and divide it by 3, right? We can put 2 in each one of those groups, if you will. Okay, I'm going to subtract that. Now I'm going to go ahead and I have 7 tenths. I can't take 7 tenths. Yes, I can. I can put 2 in each group. Okay, I'm going to have 1 left over though. Now I can bring down my 2, which was my 2 hundredths. Now I have 12 hundredths because I had 1/10. Yes, I can put 4 hundredths in each group. Therefore, look at that. The question becomes, is this, because I want you to see this. What do you notice about these two problems? I mean, are they the same? Do they differ in some way? Think about that for a second. One equation, we definitely have a divisor of 2, right? In the other equation, we have a divisor of 3. What else? Oh, look at that. Both quotients have 2 decimal places. Okay, I can see that. Something else to notice that there's difference is, you know what? The 6.72 or the 6 and 72 hundredths, it has digits in the tenths and hundredths. When we first started off with 1 and 7 tenths, it only had a digit in the tenths. It didn't have one in the hundredths, but we added a 0. Wow, there's a lot of things where they're similar and then some where they're different. And you know what? One way they differed too in that first problem, we had to think of 1 and 7 tenths, that 1.7. We had to actually think about our dividend as just 1 and then 70 hundredths in order to keep sharing, in order to keep going. Awesome. By recording at 0, did it change the amount? No, it didn't. Okay? It didn't change the amount. By putting that 0 in there, it helped us unbundle that and look at the units in a different unit form rather than looking at it as at 1/10. Now we had to look at it as, that's right, 10 tenths. Now I'm going to continue on some similar problems, and we're going to go ahead and use the value discs again. And what would be really great, there you're in your home, right? And what you could do is you could go ahead and start working along with the algorithm and see how that works out as I put up the place value discs. Wait a second, wouldn't the last guy have green? Didn't the last guy have green shades? Hey, what are you doing? Oh, I see. Oh, he's your twin. Oh, okay. Right. Okay. Now, I've seen some pretty weird things when we've done these animal features, but you know what? This guy is a little different. This guy, he takes the cake. There's no other way to describe it. Okay. Moving on, my friends. Now we have 2 and 6 tenths divided by 4. So what I'm going to first do here is I'm going to go ahead and represent my 2 and 6 tenths as my dividend. There's 1 and 2. Oh, and I have 6 tenths. Write my algorithm over here. 2 and 6 tenths. And maybe I want to take my decimal right and put up, and away. Okay. First question. Can I take 2 wholes? Can I divide it equally in 4 groups? I cannot. That's a problem. Okay, so we say that no, I can't do that. So I have to record a 0 right there in the ones place because I can't do it. But what I can do is I can unbundle those 2 wholes and I can rewrite that as 10 tenths for each whole. So that's 20 tenths. Oh my goodness, I have some work to do. Okay, so I just wanted to show you I have my 2 wholes and I've shown my 2 groups of 10 tenths. and I also have 6 up there, so I have a total of 26 tenths. With 26 tenths, I can definitely divide that into 4 equal groups. I could probably put what? About 6 in each group. So if I were to count 6, and 6 times 4 is 24. So I could cross off 1, 2, 3, 4, 5, 6. There's one group of 6. And there's my second group of 6. Third group of 6. And then my last group of 6. Leaving me with, did I do that right? Leaving me with 2 tenths left over. So I had my 26 tenths. So 6. And then 6 times 4 is 24. I'm going to subtract. Now I get left with 2 tenths. Well, I can't divide 2 tenths by 4, but again, I could rebundle. Okay, now I have my 2 tenths represented as 20 hundredths. Remember, 10 hundredths in each tenth. And now I'm trying to make groups of 4. Now I have 20. Yeah, look, that's going to work out great because I could put 5 in each group. Just so that you can see this, here's 5 right here, and I'm trying to make 4 equal groups. So just want to make sure that you understand what we're doing here. Then here I have 1, 2, 3, 4, 5. So we could do this little section here. There you go. Equal groups. So I have 4 groups because remember, that's what our divisor said we were going to do. So that we're going to make 4 equal groups, and now I've put 5 hundredths in each group. All of these are going to be divided into that dividend. Now because I went ahead and unbundled those 2 tenths, remember I can put that 0 here, and by putting that 0 there, I can create 20 hundredths, and that's where that 20 comes from. So now I can divide that 20 by 4. Now I'm getting my 20 here, and I have no remainder. Again, I have 0 ones, 6 tenths, 5 hundredths, or 65 hundredths. Now, I know some of you are thinking, Mr. Wara, are you serious? Do we have to do that every time with all those value discs? And I'm going to be honest with you. You know, part of what Common Core states is about representation, modeling and showing your work. And in some problems, they're going to expect that you be able to do this. However, what's going to happen even in our lesson is we're going to slowly move away from using the value disk and then teach you the actual algorithm. What's really important here is that you see what's happening. It brings meaning to math. So you're not going, I don't get why we're doing this algorithm. Why? Why do we drop a 0? Why do we do this? Now, by having that model, you can see how this all fits together. Okie dokie. Woohoo! Yeah, yeah. Page master. Dun, dun, dun. Wait, is it blue? Wait, wasn't the last one like purple? Oh, it's pink. Ah, I see. Uh-huh. You're changing your sunglasses, aren't you? No? Oh, really? Oh, that's not your twin, your cousins? Okay, I think I've heard it all now. This is getting stranger than fiction. Okay, you just hang out, bud. That's fine with your little sheep bell or cowbell. I mean, what do they call that on it? Do they call? I mean, everybody knows what a cowbell, right? But a sheep bell? I don't know. Maybe. So now we're looking at a whole new problem here. That's right. We have 17 divided by 4. Now, oh, look at that. You know, I almost noticed immediately. Look at, if we were to, first of all, what I noticed is we don't have a decimal, right? We have a whole number. Whoo, what a relief, right? Well, not so much, because when I look at that, I'm thinking, you know what? If we divide 17 into 4 groups, of course, 4 equal groups, we're not going to be able to do it. We're going to have a remainder. You may have recalled that when you were in fourth grade, you know, when you're just little fourth graders, you know that you actually recorded the remainder as like R1. Okay, you would say R1. I have a remainder 1. Do you remember that? Well, those days are leaving. Not entirely, but what we have done today lets us keep sharing that remainder. Remember when we had that remainder, we just would unbundle that disk and show it in a new unpacked form into another place value from tenths to hundreds and hundreds to thousands. Okay, so I'm going to do this one, but I'm going to do this one kind of rather quickly. You might see me edit this part of the video, and then maybe you want to stop the video and do your work and see how you did. Okay, so I've shown my 17 holes. I'm going to go ahead and divide that into 4 groups. Well, there you go. Woo, what a doozy. Look at all those value disks. Yeah. All right, my friends, do we have another problem? We do. Oh, yeah, and another sheep. Yeah, let me guess. You're his sister. Oh, okay. This is too funny. Yeah. Now he's saying it's his second cousin. All right. Yeah, okay. You guys are just trying to mess with me, huh? Yeah, let's mock Mr. War today. Woohoo, let's pick on Mr. War, a feature animal of the day. It's time for another one, 22 divided by 8. Now in this case, I'm going to again show you using a value disk. So this is perfect time to stop the video and then go ahead and see if you can't solve this yourself. All right. Oh my goodness, what a problem. Okay, you can see there's a lot of work and a lot of value disks that I had to use. Okay, now are we going to meet yet another cousin? Let's see. Okay, it's still you. What do you mean it's not you? Oh, really? Oh, I get it. Yeah, your fourth cousin? Okay. They're all just like one big family, huh? Or something. Okay. Now let's go ahead and do some math. Woo, sorry, buddy. Now we have 7 and 7/10 divided by 4. So first thing is I'm going to go ahead and bring up that decimal point just for my quotient. That's all. But it just so happens that we can take 7 wholes and divide it into 4 equal groups. We'll only get one of those wholes in each group. Therefore, I'm going to put my 1 up there. Now, of course, that means I have a total then that I've shared was 4. And I'm going to subtract that 4 that I shared with those 4 equal groups, and I get 3 wholes left over. Now, we have 3 wholes, but we can't share those equally. So we're going to go ahead and take those 7/10 and bring it down. So now we have 37/10. Okay, and with our 37/10, yes, we can divide that into 4 equal groups. In fact, we could probably make almost, look at that, 9. We could put 9 in each group. And if there's 4 groups, that means we have 36. So we're able to share 36 out of that 37, leaving us with just 1 left over. Now remember in the old days, you used to always say, hey, remainder 1, we're done. But now we know that we can keep going on because we have 1/10, and we can make that 1/10 into 10/100. So that's what we're going to do, is we're going to bring down our 0 to make those 10/100. So 1/10 now has been unbundled into 10/100. Now I can share that with the 4 groups equally, but I can only put 2 in each group, meaning that I have a total of 8 that I can share equally, okay, leaving me with 2 hundreds left over. With our 2 hundreds left over, we can't share that equally, right? We have 2, but we can unbundle that, and now we can make thousandths. So I'm going to go ahead and put my 0 up there because I'm not changing the value. I'm just unbundling my 2 hundreds now and making them, now I have 20 thousandths. And with 20 thousandths, I can share those equally by putting 5 in each group. And now there are no more thousandths left over. And I subtract and I get 0. Wow. Okay, now you might say, hey, much faster than the place value disk. Well, I hope that made sense. So now we have 1 whole, we have 9/10, 2 hundredths, 5 thousandths. So our standard form, the way we say that is 1 and 925 thousandths. Okay, and that is our quotient. Woohoo! Yeah. Do we have another problem? We do. So let's go ahead and practice one more. This might be a good time. Yeah, that's right. A good time for you just to put the video on pause. Wow, that one worked out nicer than the last one. Woohoo! Yeah. Now, I just noticed we got another guy with purple. Yes, you're another one that's related somehow? Oh my goodness, it's like they're all related. Okay, I think we're on the last problem. I don't know, is there any more? I don't think so. Let me see. Oh my goodness! What is this? You guys are fam for sure? Yes, I know, you're all related, right? Yeah. What's up with it? What do you got? Some kind of tie-dye going on in your wool? Okay, yeah, I'm sure. Yeah, somebody wants that colored sweater. Okay. I always think I've heard it all, and then someone new comes along and proves me wrong. Hey, my friends. Oh my goodness, my eyes are getting all blurred for all the sheep. It is time to say adios. It's been real. It's been fun. It's been real fun. But now, live long and prosper, my friends.